Hello, hello everyone. Hello, hello, hi. Hope you are doing well. I'm Mahendra. Welcome to my YouTube channel. Today, usually I'm going to wait a minute. Let me off my stick camera. Yeah, I'm good. So today, in previous my videos, I have shown how to download the R and how to get the working directory and how to set the working directory. So in this video, I'm going to show you how to import the files, maybe Excel files or CSV files, and how to make some graphs out of this so that everyone can understand your data. And some simple descriptive statistics like how to calculate mean, median, mode in the R. So I opened the R. I already made one file to which I wanted to make as a working directory. We can just go back in the my desktop. I have made one R demo file, so that is my working directory. So I want to make this as a working directory. So these are the files which I need to import to uh, R. So I just want to know the location of this file. You can just open this file, and if you click here, so this is the location of R demo. You can just copy this, Control C, and go back to R Studio. You need to first just set the working directory. This is what I have showed before. Set working directory, write the code, put this comma, copy paste. So R doesn't accept this kind of clashes. We need to use the opposite slashes. So just left side to the shift, there is one button which gives this kind of flashes. This one just change it. This and this and control enter. So we have set the working directory. You can just check it by doing get working directory. Uh, get working directory. Yeah, see, this is our working directory. Now we are going to import the Excel file. Usually for the Excel file, there are a lot of packages we need to install, but there's one proxy method in the R. Just that we can directly import the Excel file. Usually for the CSV files, we need to write read dot CSV this thing, and we can put the file name here. Suppose file name is demo, and if we want to header, I mean the heading line we need to include. If you want to include that, make it true, and yeah, but I don't have a CSV file now, just I'm showing the Excel file, so I don't want to use this formula. So you can just go to here, import dataset from Excel. Will open, will pop on one window where preparing data import. Yeah, whenever we install first, it needs to download some packages to read the Excel file. So I'm giving S for this. Uh, so it may automatically download. Yeah, they downloaded some image console, something is downloading. Now you can try now. Click from Excel. Wait a minute. Yeah. Whatever accessories packages needed for Excel, it's going to automatically download. It's taking some time. Uh, Whenever you download the yeah, now it's open. So these are it has downloaded read.excel. Read Excel. So this is the library package. Whenever you want to use the package, we need to open library. We need to type the library and we need to put the package in the paras. So I'll go back and maybe I will show you how to do all this. How to close this. From here, go to browse and we need this file. Open it. And this is retrieving the previewing data. Yeah, browse is the planted genotype. You can also select whichever sheet you need. I have only one sheet here. I don't have any data in sheet 1, sheet 2, and sheet 3. Just I'm selecting default. There's the sheet 1. Then just go there. import. Cancel this. Now I imported the data. You can just see here. Genotype, plant date, location. This data is also here. You can just write this comment. If it doesn't it doesn't open automatically, you can just write the comment view whichever the file. The R is very case sensitive. I mean, uh, if the letters are in very small letter, you need to write the small letter. If it is in capitals, and you write the capital letter. It's very case sensitive. So my file is always I usually write in small letters for convenience. Just control it. Sorry, I need to give because there is a character. It here. View. View. I don't know what's happening. So if it just, I mean, it's not required. If it just, if your data frame is downloaded, you can just click on this. You can capital V, I think. Check. View demo. Yeah, I told you the R is case sensitive. For view demo, the V should be capital letter. That's why I didn't get. I was writing the small v. Whatever you write the code, you can write the code here and you can execute in the console. You write and you can just click on the code. The cursor should be on, and you just enter control enter. The code will be executed here. So just give them. So you'll get the genotype, plant type, and location. So let's go to our previous walkout. We have set the working directory, we have checked working directory or imported demo file, and we have seen what is the structure and everything. You can also see like what is the structure of the file, and if it is a large file, we just want to see what is there inside. You can just also write head demo, control enter. So it will show what is there. First six characters it will show. The genotype is there, planted is the location, first six character value will be there. And you can also put the structure str and demo. It will show this is the data frame. That's what we wanted. And see whatever the values here, it's a numerical. This is the heading. This is the plant type. This is also numerical, and the location is a character because this is not a numerical. We have Delhi, Bangalore places. And you can also check what kind of demo is a what kind of thing. I mean, it is a character, it's a data frame, something else. If you want to check, you can just put the class demo. I say it should show table data frame. It's a data frame. So if you have only data frame, then only we can do all the statistical analysis. So we have checked these basic things. Then if you want to just calculate uh, some descriptive statistics. So suppose you want to calculate mean of the planted. You just type mean. Our file name is demo. Just put the dollar sign so that it will select whichever variable it want. See, you will get this. Plant height is the numerical value. Just put the plant height, control enter. See, you will get the 31.433 is the main value. If you just want to do the median value, just put this, copy. I already written the course previously. Is the median. I don't know. Why so? Let me write. Median demo plant height. So this is the median 29. So these are I think the basic things you can do. You can just play and you can do the standard error, mode, everything. So next, if you want to plot, there is one uh, default function in the R, the plot. It just gives the scatter plot, how the values have scattered, how the values were distributed. So just give the picture of that. You can just use this the plot function. You can just put the plot plot and you can make the demo. You can put the dollar sign, the plant height. Just control enter. See, you will see the plot here. And suppose you want to plot plant height and the genotype. Take the same code. You put this. I mean, there is one character here below the escape button. Shift this one and you put demo plus sign genotype. Control enter. See, this is the genotype and this is the planted. How one gene like three locations. So three data points. How they are distributed. So this is a basic thing we can do. I'm just gonna remove this. Suppose you want to make in three different locations how genotypes has shown their phenotypic value. I mean, how the plant height has changed. If you want to show the trend line, I mean, multiple, all three graphs in the same chart, how to make this? You can do in Excel also, but you will not get as beautiful picture you get in the R. And this is also like customized. You can customize according to you. And if you just if you have done the if you have set the all these codes, and you can, if you want to do for other data file, you can just need to change the file names and variable number. It will just give the same thing. So that's why R is very versatile. For this you need to download some packages. You just go to install dot packages, write the code install dot packages. First you need to download this readr package. Put this commas, read R, control enter. So it will install by itself. See, it's already installed. So this button is, I mean, it shows this R button, red button. It shows something is, some program is installing. Uh, then install that packages. I will just copy this. Just here dplyr. Control enter. Install that packages. ggplot2. Yeah, this is the mine package. These are all accessories, but the ggplot is the mine package. ggplot2, control enter, then install dot packages, we have scales, control enter, then quantum mode, install dot packages, 1 minute is running, install dot packages, quant mode, is control enter. So this is all 5 packages we have installed. So whenever you want to use these packages, once it is installed in your R Studio or R program, it will be saved in R Studio. So no need to reinstall it again. But whenever you want to use this, you just need to write the you just need to open that package. For that opening package, we use the code library. So here we don't want to use this symbols. It just used to we just need to use this for installing packages. Here we just need for library, we just need this. So I have written all this library. I just want to open all these packages. You can just select all this, control enter. It's opening all these 4 packages. Sometimes it gives errors. No need to worry about that. Due to some R version or something. So we have got the data file. We just want to plot it, the trend line. So for this, I will forever drag this here. Okay. So I'm going to do all this in ggplot. So ggplot is very versatile and very easy. You can do also in normal basic without any packages in RStudio, but ggplot is very good. I will just, you can just give any name, like suppose I will give R, then this one R equal to ggplot. So we have, yeah, ggplot as came. We have data. Our data is equal to demo. This aesthetic means what we need to plot. Aesthetics is a code again. The x-axis is equal to genotype. Genotype, we need to make sure that the issue is very case sensitive. We need to write the same trait name what we have given in the data. Y-axis should be plant type, plant, comma, plant type, color. How color is equal to location. Uh, So this color is equal to location tells on what basis we need to make these trend lines, give different colors. So locations we have three: Delhi, Bangalore, Chennai. So we need to differentiate three trend lines showing Bangalore, showing color, showing Delhi, and showing Chennai. That's why I put color is equal to no color is equal to location. This one, yeah, location. Color is equal to location. Close this. Plus geom for line. So this is the package for this is the code for line graph. Geom line. You can just put the size, how much size you need for the graph line. Size is equal to suppose I put uh, 0.7. Okay. So just execute this and just execute this and write print or you can see the graph here. So this is the graph. See, you get the graph. Class. So this is the genotype and this is the plant type. So it will all give legends everything. This is the location. So in the Chennai, see this is the, the green color. This is the trend line for Chennai. This is the trend line for Bangalore, and this is the trend line for Delhi. And this is the genotype, and this is plant type. Genotype we have made 1, 2, 3, 4, 5, 6. So we can just see showing 2.5, 5, 7.10. The genotypes can't be off. We can just change this trend line. So for that, we can just go to here. Uh, um, you can also add if you want to remove this dark background. You can just execute this code. Just a different code here. You can just so whatever we have uh, done for G, like I mean this is for R. So remove this. So you can add on what are the extra adjustments you need, extra other things, specifications you need for this R. This R is this whole thing. For next thing, like if you want to change this background color, everything, you can just have written G earlier. You can just R plus whatever the codes you need. So this is the theme. The grid color, I mean, when we want element is equal to blank. The panel grid color again blank, and this panel background element blank, axis line in again blank. We'll show this code here, whole code. This is the whole code. You can just execute this. This, I mean, you will get the blank one. See, see everything. This background effect has gone. And it's now very clean. This is the bigger code. If you want to make only small code, you can just go to here. Maybe you can put R1, the new one, R plus. You no need to execute this. From here, directly get R plus theme, this one. You can just click here, control enter, you will get the same one. And print R1. Print R1 here, again, same thing. See, you will get the same one. Same one. And this little different, easy to read. See, a lot of grid lines are there just to compare the values. No need to write this very big code. You can just take whatever the R here plus theme this one. The print or Suppose you want to change the colors. You don't like this green, red, and blue. You want to change other colors. So you can go to, there's a color snippets in R. You can just write here. Go to Google. You can just write R color codes. So you can just open here any RGB color codes. So for every color there is a value. Suppose if you click here, so there will show the some color codes. Color codes. You can just copy this and you can put it here. So here I have made a file. Maybe I will locations. This is the location color. This is any file name you can give. C is, I mean, this code C. It means it combines the whole values. So for Bangalore, I have given this color. For Chennai, I have given this color. For Delhi, I have given this color. So I want to change these colors here. So this is the R2. Whatever we have done in R1, we are adding the extra code for that. So R1 plus scale. This is the new code. Scale underscore color is manual. Values is equal to this file line. So we just execute that, and if we print this R2, subject R2 not found. Why? Enter R1, R2. Yeah, we didn't execute this. Missing values of the local color. Oh, I didn't execute this. Need to execute all these things. Executed, and now it execute this code. Now I need to. So earlier this colors for there. Now we are going to, colors will be changed. See, colors will be changed. So we got Chennai as a black, Bangalore as a red, and Delhi as a green. So this is all thing. Again, if you want to change the axis titles, you can just add another code to this. We are making new file, new object R3 or R2. We are going to add this functions. So labs is the function to add genotype. I mean x-axis label and y-axis label. So x-axis we need genotype, for the y-axis we need plant height in centimeters, and we also make the break. If you want to concentrate on only one part of this, you can also make the breaks. Suppose you want to 22, 20, 22, 30 like that, you can also make the breaks. So from the values we have, using the break function, that we want to start the axis from the 20, you want to end around, see the final is around 65. So you can put the 65. If you don't want to put also, it will take automatically. If you just want to customize, if you want to customize for every 5 centimeter, you can just put here or 3. Just execute all these codes. So now it will show, see, 20, 25, 30, 35, 40, 45, 50, 55, 60. This is the plant rate and this is the genotype. This or suppose if you want to make any changes in the, if you want to increase the this boldness of this boldness, these things, you can just if you want to change this location somewhere in the below, you can use this codes. It will just we are just adding on this code to R3 again. We'll give the new name R4 and this is the R3. There's a theme function. Axis.text is equal to element text space is equal to bold. We are getting, we need to have those bold values. Size you can give anything. And theme legend.positions. The legend should be in the bottom and print R4. You can see, you can look all this code in one. This is the code. To print this, what happened? Theme axis. Yeah. See, this got become bold and this got extended, and the legends got came below location Bangalore, Chennai, Delhi, everything. So if you want to combine everything in one file, scale y dot continuous. You can also make because it's 2.55 7.10. So we need to make this one. Uh, this one because genotypes we need to have one, two, three everything. You can just use the same function here. Scale dot y continuous. We need to go for scale dot x continuous. So put it here plus need to modify according yourself. Scale if just put x here. X continuous breaks is equal to we don't need any breaks from 1 to from 0 to and from 1 to how many genotypes we have from 15 10 by 1. Just click this, let me see. Yeah, print. Yeah, alas. See, now we got genotype is a 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and the plant it is this much. So you may be wondering, oh, this much code to write to this one to make this simple graph. So you can combine all these codes into simple code. This is the code in one. I mean, you can just execute this. You will get the this graph. So I have added new uh, code here. I just going to add. I'm going to just add this code into that whole code I have made. Let me copy this. So this is the whole code. I'm going to add this to a new code. Yeah, you can just add it here. Yeah. So this is the whole code. You can just have a look before I'm going to run this code. So this is the G1 we have written the same. Yeah, we have combined all this from G1 to G4. Whatever we have written, we have combined in one single code. So this is the G1 we have given. G plus this is the G1. This is the G. Sorry, sorry. Maybe confused. This is the R1. It should be R1. Uh, and this is R. So you can just take this one. Let me show. Delete everything. No, it's not required. Just combine all. Yeah. Just run this code. Even you cannot. You don't want to run this separately. You can add here only. Just add this here only. Control C. Add here. This is the R code. Right. Delete. You can just go to R. Delete this. Not required. This is the old code. Forget everything. This is the old code. You need to right print. Yeah. So we need to have ggplot. Does the library, does the package data is equal to demo aesthetics, x is equal to genotype, y is equal to plant type. This is the we are running code. Color we need to separate by using location. And this is the gm dot line. Which function we need to use? So gm dot line is there, gm bar is there, bar is for bar graphs, many things. So we just we do the scatter. I mean line trend line. We were using gm dot line. The sizes of the line should be I mean zero point 0.7. The scale color manual values is equal to I mean whatever I have made this. If you don't want to make separate uh, colors for this, I mean you don't want to customize, you can just delete this. Not required. You can just delete this because this seems to be very heavy for you. Labs x is equal to genotype, y is equal to plant type. That's what labeling the x-axis and y-axis. And plus scale y continuous breaks, how much you need, we have just changed this. I think we just took from 20 to 65. 65 by 5. Theme axis, this is all bold size, whatever you need, just element base, everything. And the scale y x continuous should be 1 to 10. The genotype y is equal to 1. Theme legend title, do the same course I have explained up to side. Uh, you can also delete this. Suppose if you don't like, you can Just go for theme this code. I mean, this one. So take this whole code and run it. This is the whole code. Uh, Sorry, can you see this whole code here? All right, I don't know how to show you. We'll just like do like this so that we can see the whole code. Theme continues from here. Yeah, this is the whole code. This is the whole code. You can just have a look on this and you run this code. Select this, control, enter. X is equal to genotype. There is some error it's showing. ggplot data is equal to demo. X is equal to genotype, plant type, some error, ggplot data is equal to demo. Some X is equal to genotype. Why? Let me run it. Oh, yeah. So let me run this here. Wait a minute. Same code I have run here. X is equal to plant type, genotype, and plant type. X is equal to, let me run this again. X equal to, oh, I didn't use the lab function. That's why it's saying labs. Right? Now it will show. Yeah, it can. So just print R. Okay, get the picture here. So this is the everything we got here. You can just add this to remove all these backgrounds. Theme. This is the whole graph we got. And if you just don't want to run all these codes, you can suppose you just want a simple graph, you can stop by here only. I mean, you can run this, and you can add this one labs function, and you can stop it there only. I mean, suppose you just want to have simple graph, you can run this code, and you can run this one, and you can stop it.